Number 3. The goal for this problem is to write the equation of this exponential function. All exponentials are in the form y equals a times b to the x, where a is your starting value, b is your base, which is also known as the growth or decay factor, and then x is time, but really that only comes to when we do word problems. Alright, so the first thing you need to identify is what kind of exponential function we're dealing with, a growth or a decay. A decay, because from left to right, isn't that function decreasing? It's going down. That lets you know what about your b value?
Less than 1 or greater than 0.
Very good. Your b value will be somewhere between 0 and 1. B can never be negative. It's either between 0 and 1 or it's greater than 1. Now, we also need to know our a value. Well, I already said a is the starting point, and where do you find that on the graph? The y-intercept. And this one's a fraction y-intercept, so just so that everybody's on the same page, we'll go with 1/3. Okay, so now look. We have a that we can plug in right there. We can plug in 1/3. We don't know b. All we know about it is that it's going to be between 0 and 1. What else could we find out so that we can solve for b? A point. What point looks like it would be nice to use? -4, 5. Okay. Now, it's not a possibility this time because you didn't have any nice points on the positive x side. But if it's possible, it's better to pick a positive x value. Okay? It's not always possible, but if it is, pick a positive x value. It'll be less headache when you're solving for b. But like this one's not possible, so we had to go with -4, 5. So now look, isn't that -4 an x value and the 5's a y value? So when I write it in the equation, 5 can go in the y place, 1/3 goes in the a place. We don't know b, that's what we're trying to figure out, and then x is -4. So now to solve for b, what would I need to do first? Divide by divide by 1/3, or what's our other option? Multiply by 3, okay? If you don't want to divide a fraction by a fraction, you can always multiply by the reciprocal, which would be 3. 3/1 is 3. But regardless of which way you do it, you end up with what on the left? 15. And on the right, you have a b to the -4. Okay, now let's talk about how to get rid of that -4. A rule about exponents that you've got to learn, or you've got to remember, because we've already learned it this year, is that when you raise a power to another power, they multiply. So, let me say that again. When you raise a power to a power, you multiply it. Well, don't we want this to be b to the first? Because b to the first is just b. So we want it to be b to the first power. So if we raise it to another number right here, -4 times what is 1? -4 times 4 is -16. No, -4 times 0 is 0. Okay, well first of all, if you want it to be a positive 1, doesn't it have to be another negative number? Because a negative times a negative will become the positive? Which is 1/4, which is the reciprocal, right? If you want to cancel out an exponent, just raise it to its reciprocal. -4 times -1/4 is just positive 1. And so now though, since we raised this side to the -1/4, you have to raise 15 to the -1/4. And what is 15 raised to the -1/4 power? .5, so about 1/2. And isn't .5 between 0 and 1? Okay, so our equation is y equals a, which is 1/3, b, which is 1/2 or .5, however you want to write it, to the x power. Now, they won't all be that difficult if you can get a better number for your x value than -4, but sometimes it's just not possible. Like there was nothing over here that was going to be a nice x value, okay? Because that's where the asymptote is. But most of them, there is some stuff on the right where you can pick a positive x value, and it'll be easier for you. Okay, now let's go to the next page. Oh, we didn't do domain and range. What is the domain of any exponential function? Correct. All exponential functions go left forever and right forever. They will all have that domain every time. What about the range? Zero, because that's where the asymptote is, so it'll never go lower than the asymptote. And then how high will it go? Infinity. Okay, once you've copied that, turn to the next page. Okay, number 5. Is this a growth or a decay? It is a growth because from left to right it's increasing. And a growth tells you what about your B value? It's what? Greater than 1. Okay, we can also figure out the A value. What's the A value for this one? Where does it cross the y-axis?
Like 1/3.
1/3. Yeah, I'd go with 1/3. Okay? Let's now pick a point because remember to fill in for the equation, we don't know B. All we know about B is it's going to be greater than 1. But we now know A, and can't we pick an X and a Y from the graph? So what do you want it to be? Right. Anytime you can pick a point with an X value of 1, that's going to make your life the easiest. Okay? If your X value is 1, it's going to be super easy. So now we have an X value of 1, a Y value of 2. So we plug everything in the letter it goes in. Now how do we solve for B? Right? You can either divide by 1/3 on both sides or multiply by 3 on both sides and you get 6. And then isn't B to the first just B? So that's why it makes it very easy whenever you can pick a point with an X value of 1. Now we have everything we need. Y equals A, which is 1/3, times B, which is 6, to the X power. There's your equation. What is the domain? Correct. And what is the range? 0 to infinity. Okay, why don't you take a second and try 6 and 7. For number 6, what equation did y'all get? For number 6? Right, 2 and then times 2 to the X power. What did you get for the domain? Correct. And then the range? Right. Okay, that's the equation you should have got. It starts at 2, that's its y-intercept. And then when you picked a point, plugged it in, no matter what point you picked, you should have got a B value of 2 as well, which makes sense because it's greater than 1 and we're dealing with a growth. Okay, number 7. What equation did you get for number 7? Y equals 1/2 times 6 to the X power is correct. What did you get for the domain? Right, that's what all exponentials domain is. And what about the range? Right, now on this page, every single range has also been 0 to infinity so far, but is that always going to be the case? No, the only reason that every asymptote has been at 0 is because for every single one of these, there's nothing added down here in the k place. Okay, but you're going to have exponential functions that go up and down, which will move your asymptote up and down, which will affect your range. Okay, number 8. What's different about number 8? It's upside down. So it's obviously been reflected over which axis? The X. So if you reflected it back, doesn't that mean it would have looked like this before? So what are we dealing with, a growth or a decay? Decay. Because think about it, it would have looked like this before the reflection, and that's decreasing, which is a decay. So right away we know our B value is less than 1 but greater than 0. What is our A value this time? -5. Doesn't it cross through the y-axis at -5? And that's what caused that reflection because the A value is negative. Okay, so it went down there. What point would you like to use? -1, -10. That looks like, because there's really nothing over there that goes perfectly through. And so -1, -10. So that'll be -10 in the y place equals -5 times b to the -1 power. So to solve this for b, what would you do first? Divide by -5. So now we have 2 equals b to the -1. Since it's -1, you can't just stop. You have to get rid of the -1. And what can we do to get rid of it? Nobody knows? What? No, you can only square root it if it's squared. Right. Raise it to its reciprocal. Well, what's the reciprocal of -1? -1. When it's a reciprocal, you don't change the sign, you just flip the fraction. Think about it. 1 is 1 over 1. Oops. So if you flip 1 over 1, aren't you going to end up with 1 over 1? So the reciprocal of 1 is 1. But you do have to raise it to a -1 because a negative times a negative is what makes it +1. So now we have b to the first equals 2, but since we raised that to the -1, you must raise that to the -1. And what is 2 to the -1? .5. Does anybody know how 2 to the -1 becomes 0.5? Because the negative does what though? We learned this earlier this year. Remember, back when we learned exponents, if you're ever wanting to get a negative exponent to become positive, don't you just have to move it to the bottom of the fraction, or vice versa if it's already on the bottom? And so to make 2 to the -1 become 2 to the +1, just move it to the denominator. And now don't we have 1 over 2, which is 0.5? So that's how 2 to the -1 becomes 0.5. Okay, so now we have everything we need to write our equation. Y equals a, which is -5, times b, which is 1/2, or 0.5, to the x power. What is the domain? Correct. Even though it's been reflected, it still goes left forever as it's going down, and as it goes up, it's going right forever. But now this time, what would the range be? -infinity up to 0. You always go down, then up. It'll go down forever, and then it'll only go up to 0 where the asymptote is. Okay, so why don't you try number 9? Okay, number 9. Is this a growth or a decay? It is a growth. Okay, because think about it. Before it was reflected, would it have looked like this? Okay, that's what it would have looked like before they flipped it over. So that's a growth that's been reflected. So that means our b value will be greater than 1 because it's a growth. What is our a value? -5. And that negative is the reason it got reflected, because it had to pass through -5 on the y-axis. What point would you like to use? 1, -10 will be nice. Anytime you can use 1 as your x value in your point, it'll make your day a lot easier. So now we plug in everything we know. We know the y value is -10. We know the a value is -5. We know the b value is what we're trying to solve for. And we know x is 1. Now what do we do? Divide by -5. Pay attention. Divide this side by -5. So b equals 2. So now you have everything you need to write your equation. Y equals a times b to the x. So the domain is correct, and that's what it is for any exponential equation. And the range this time is correct. You can go down forever, but you can only go up to where the asymptote is, and since it flattens out right there, it must be a 0. 10. Are we dealing with a growth or a decay? A growth, which goes ahead and tells you what about your b value? It's going to be greater than 1. And it's a good thing to have that kind of information in your head, because if this is a test and you're dealing with multiple choices, and you see some choices that have b values that are not greater than 1, you already know to mark them off. Okay, your b value has to be greater than 1 when you're looking at a graph that increases. What is your a value this time? 3. What point looks like a nice one to use? 1, 6. So it will be 6 equals 3 times b to the first power. Now what do? Divide by 3, divide by 3, so b equals 2. So our equation is y equals 3 times 2 to the x power. What is the domain? Correct. That's what it is for all exponential functions. And what is the range? Correct. The lowest it will ever go on the y-axis is 0, because you can see that that's where the asymptote is. The highest it will go is forever. Okay, what we're about to learn about next on page 10 is logarithmic functions. Now, the important thing to know about logarithmic functions is that they are the inverse of exponentials, like inverse operations. So everything's going to be the opposite. Instead of having a horizontal asymptote like we've had on all of these, we're now going to have a vertical asymptote, an up and down asymptote. So, think about it. Okay, let me say that again. Logarithmic functions are the inverse of exponentials, which is what we've been doing. Exponentials have a horizontal asymptote, which affected the range, correct? Logarithmic ones are going to have a vertical asymptote, which will affect the domain. So with logarithmic, the range is going to be all real numbers every time. It'll be the domain that changes from problem to problem, depending on where the asymptote is. Okay, so let's look at one. Okay, one thing you need to realize is the parent function of a log function is just log base 10 of x. That is your parent function for a logarithmic function. So let's look at what that looks like on the calculator. Y equals, see this word right here, log, and then if you put in x and you graph it, that's what a parent function of a log looks like. Now, what you cannot see, the calculator for some reason just doesn't continue drawing it, is that see how right here it makes this turn? It actually keeps going down the y-axis. The calculator doesn't continue drawing the line, but it continues going. Okay, otherwise this just looks like a square root function, right? Now let's type in our function. Okay, but listen. When you type in our function, it is not log base 10. It's log base 6. So you can't just simply use that log button. Okay, because the log button that you see right beside the 7 is always base 10. Okay, so you can only use that button when your base is 10. If your base is something other than 10, you have to go into math, and then you go all the way down until you see the word log base. There it is. Okay, does everybody see where to get to log base? You hit math, and then you just go down until you see log base, and you hit enter. And see how now it gives you an option to type in whatever base you're dealing with? So you type in 6, and then inside the parentheses, you would type in your x minus 1. And then on the outside parentheses, you type in your minus 5. Now, just for a second, in red, I'm going to type back in the parent function for a log so that we can compare. Okay, so remember, blue is the function we're working with, red is the parent function. Okay, so look, here's where the parent function started, here's where ours starts. So what kind of transformations occurred? It definitely went down. How many notches? 5. Okay, because look, see how that one starts at -1, and then down 2, 3, 4, 5. Well, I need to go there. I can count. 1, 2, 3, 4, 5. You're looking at like the turn. Okay, and then see how it moves to the right 1 unit. Look, right 1, down 5. Okay. So just like always, the number inside with the x moves it left and right, and it's the opposite of what you would think. The number on the outside moves it up and down, and it is what you would think. So this is right 1, down 5. Okay, well, to put that on the graph, the easiest way to do it is to get some points. But before we do that, I'm going to go ahead and take out the parent function just so we don't get confused at what points we're looking at. Okay, so second table. Okay, see how when you get to 1, and then if you go left to 0, then further left to -1, it says error? Well, look, isn't that because you can see that it made a turn right here because there's an asymptote sitting right there, a vertical asymptote? So there's nothing over there. And that's why in the table you see all of that as errors, because there's nothing over there. So the first nice point we can plot is 2, -5. So go ahead and plot right 2, down 5. Then another nice point is 7, -4. And it looks like that'll probably be the last one we can fit on here. Now, even though you can't see it, you can see on your graph in the picture how it gets over here and then it makes a sharp turn and starts going down. And it continues to go down forever, even though the calculator doesn't show that, because there's an asymptote right there at 1. So you would just turn it at 1 and continue to go down forever. So go ahead and draw in your asymptote line. Okay, so if this one has an asymptote that goes through the x-axis at 1, where do you think the asymptote normally starts out with a parent function? 0. Just like with the exponentials. Oops. With exponentials, you know how it always just went straight across the x-axis before you shifted? Well, now it goes straight down the y-axis. But this right 1 shifted everything right 1, including the asymptote. So now that we have a picture, let's do the domain and range. What is the domain this time? How far left will you ever get on this graph? 1, but you never actually touch 1 because it's an asymptote, so you put parentheses. How far right will you go? Positive infinity. Okay, now let's talk about the range. Does a vertical asymptote affect how far down and how far up it can go? No, think about it. It can still go down forever, and as you're moving to the right, isn't it slowly rising up forever? So this time, with logarithmic functions, it's the range that will be all real numbers. Because remember, I said they're inverses, so everything's the opposite. Okay, so now let's look at number 2. Okay, what kind of transformations are we going to see? What kind of shifting? Right 1 and up 3. Okay, so now let's put it on the graph so we can get some points. Y equals, how do I type in log base 5? Bad. And then you got to go, I just go up because it's at the bottom, so it's faster just to up to get there. And it's a base 5. Then inside parentheses is x minus 1. And then outside parentheses is plus 3. Okay? Alright, so now we need to go to second table to get some points. See how everything from 1 and to the left has error because there's nothing there because the asymptote kept everything from going to that side? So our first nice point is 2, 3. Then we can put 1 at 6, 4. Okay, and then we know that because it moved right 1, an asymptote would normally run right along the y-axis for logarithmic functions. But that right 1 moved the asymptote right 1. Okay, so the logarithmic function will look like this going to positive infinity, and then as it goes left, it will approach the asymptote forever. Okay, so what does that make the domain? 1 to infinity. And what does that make the range? Correct. And remember, that's what it will be for all logarithmic, just like for exponentials it was that. Okay, why don't you try number 3? What kind of transformations are going to occur? Right 3 and then down 5. Okay, so when you graph it, it will look like this. So 2 nice points that I found on it were 4, -5, and then even though it goes off a little, you can pretty much plot 9, -4. So where is the asymptote this time? 3, because everything got shifted right 3, including the asymptote, to draw it in. Okay, and then on this side, it just approaches the asymptote forever. Oops. So that makes the domain what? 3 to infinity. And the range, negative infinity to positive infinity. Okay, quickly turn to page 12 so I can explain your homework really quick.
Oh.
Shh. Okay, all you have to do on page 12 is identify the domain and range. Well, to be able to do that without actually graphing it, you have to know how it shifts. So how is number 1 going to shift? Left 1, down 3. So picture it in your head. If the whole thing shifts left 1, down 3, how does that affect the domain? Negative 1 to infinity. And then the range for any logarithmic function is correct. All real numbers. So that's all you have to do for page 12. Okay, make sure you write it on your pink sheet. Today's the 16th. You may switch out.